talk to you about the use of chemistry in the first world. Some days ago was the anniversary of the world marks 100 years since first use of chemical weapons in chlorine gas, attack which left thousands of victims drowning in their own lungs. German forces launched first attack using gas in April 22 in 1950. 150,000 tons of gas were used by German and Allied forces in the First World War, and around 1 million soldiers were exposed to gas and 90,000 killed. As a spring breeze wafted into his trench, French commander Georges Lemur saw something surreal drift his way, a yellow-green cloud. "All my trenches are choked," he cried into the field telephone to her waiters. "I am fouling myself." Chlorine gas, carried by favorable winds over Flanders, fell from German positions. Had been used for the first time, it was April 22 in 1950. Victims were often temporarily and sometimes permanently blind, and they took weeks, sometimes months, to recover bogging down from child medical facilities. When the poison killed, death took up to 4 or 5 weeks. This entire horrible episode continues until the last gas attack came just 3 days before the Artemis of November 11 in 1980. Historians estimate that more than 1 million soldiers were exposed to gas and 90,000 killed.
A lot of the most important medical progress in recent history has come from the development of powerful antibiotics and vaccines to treat infectious diseases caused by bacteria, viruses, and parasites. But those breakthroughs have come with a cost. Microorganisms have learned how to fight back and with a vengeance. The misuse of antibiotics is the most common reason why antibiotic resistance is such a significant problem in public health. These drugs are sometimes overprescribed by doctors, and many people fail to finish a full prescription. What's the problem, you may think? The problem is an antibiotic drug treats infection by knocking out hundreds of strains of sensitive bacteria in the body. But left behind are so many non-sensitive or resistant strains. With no stops in place, the resistant microbes repopulate themselves quite rapidly. Methicillin-resistant Staphylococcus aureus, or MRSA, is a bacterium that causes difficult-to-treat infections in humans, and its prevalence has been on the rise. Making matters worse, MRSA has become resistant to most disinfectants and antiseptics used in hospitals. Chemists are well aware of the public health danger posed by MRSA and other resistant organisms. They are working hard to outwit microbes that develop resistance. New forms of antibiotic drugs are currently in the pipeline, and researchers are trying to design them to target vulnerable molecular regions of enzymes within bacteria. And that's the role that chemistry plays in medicine. The chemists synthesize almost every single medicine we know.
The chemistry in food is similar to the biochemistry. Its main components such as carbohydrates, lipids, and protein, vitamins, minerals, enzymes, food additives, flavors, and colors. Some examples are changes of food. When the food is burnished or fritured, the atoms are more fast. Quality and taste. The artificial flavors are chemical compounds that make the food taste different. Also, the chemical may change the composition of the food and its ingredients. The food preservatives are substances that are added to the food and it prevents the generation of pathogens. Other examples of chemistry include transgenic foods that are made of organisms' chemical chains to produce the desired characteristics.
And now, chemistry and the global warming. The gradual increase of the Earth's atmosphere is believed to be due to the greenhouse effect. In the last 20 years, the amount of carbon dioxide in our atmosphere has nearly doubled. Average temperatures in Alaska, Western Canada, and Eastern Russia have risen at twice the global average. At least 2 decades were the hardest decades in 400 years. Arctic ice is rapidly disappearing, and it's predicted that the Arctic may have its first completely ice-free summer by 2040. Coral reefs, which are highly sensitive to small changes in water temperature, suffer the worst bleaching in response to stress every quarter. Things such as deforestation, pollution, and industrialization have greatly increased the concentration of water vapor, carbon dioxide, and nitrous oxide in our atmosphere.